Welcome back to The Explainer. Today, we're going to talk about the absolute most important first step when you're building a database. It's the architectural blueprint, the thing that guarantees your project is a success long before you write even one line of code.
I mean, have you ever really thought about what it would be like to build a database with no plan at all? It's kind of like trying to build a house without a blueprint, right? You just start throwing up walls, laying bricks. But wait, where are the doors supposed to go? Is there even a second floor? What about the plumbing? Yeah, it's going to get chaotic fast.
And that's exactly what happens in the data world all the time. It is a total recipe for disaster. So many projects completely fall apart because people skip this super critical planning stage. They just jump right into coding and end up with something that's, it's unstable, it's confusing, and honestly, it's pretty much useless.
So to avoid all that pain, you absolutely need a blueprint. And that's what we're doing today. We're going to learn how to draw that data blueprint using this really powerful tool called an entity relationship diagram. Think of it as our treasure map, the thing that's going to guide us from just a simple idea all the way to a working, solid database.
Okay, so let's dive in. What exactly is this blueprint for our data? Well, at its core, we call it a conceptual model.
And the key phrase here is high level. I mean, at this stage, we are not worried at all about the details. We don't care what software we're going to use or how the data is going to be stored on a hard drive. No. It's just like being an architect. You're just deciding, what rooms does this house need? How do they connect to each other? You figure all that out way before you start worrying about what brand of nails you're going to buy.
All right, every great blueprint is made of a few fundamental parts, right? And for our data model, there are really just three core building blocks that we need to get down. So let's break them down.
First up, and this is the big one, is the entity. The easiest way to think about an entity is that it's just a noun. It's the main things, the people, places, objects, in our system that we absolutely have to store information about. So, for example, if we're building a system for a university, what are the big nouns we need to track? Well, obviously we've got students, we've got courses, we need professors, and of course departments. Each one of those, that's an entity.
Okay, so if entities are our nouns, we're going to need some adjectives to describe them, right? And that's exactly what attributes are. For our student entity, the attributes are just the details we need to know about them. Things like their student ID, their first name, maybe their major.
But here's where it gets interesting. Not all attributes are the same. Some attributes, like date of birth, are what we call stored. We just save it. But others, like age, can be derived. We can just calculate it from the date of birth whenever we need it. And then you've got single-valued attributes, like a student has only one student ID, versus multi-valued ones. A student could have multiple phone numbers. Seriously, thinking about this stuff now saves you from so many headaches down the road.
So our final building block is the relationship. And if entities are the nouns and attributes are the adjectives, well, relationships are the verbs. They're the action words that connect everything together. A professor teaches a course. A student enrolls in a course. See? These verbs are what show us how all our different entities actually interact with each other.
Okay, but just drawing lines between our nouns isn't enough. A good blueprint needs rules, right? Strict rules to make sure the whole structure is solid. In the world of data modeling, we call these business rules, and they are absolutely critical to get right.
So the very first rule we need to define is something called cardinality. Now I know that sounds like a complicated word, but it's actually super simple. All it does is answer one question. What's the maximum number of connections you can have between two of these things? And really, cardinality just boils down to three main types. You've got one-to-one, like how a department can only have one chairperson. Then there's one-to-many. Think about how one professor can teach many different courses. And finally, you have many-to-many, where lots of students can enroll in lots of different courses. That's pretty much it.
Okay, our second rule is called modality, and it's just as important. If cardinality told us the maximum number of connections, well, modality tells us the minimum. It basically answers the question, is this relationship mandatory or is it optional? Does every single professor have to be teaching a course? Or is it okay for a professor to not be teaching anything right now? That's what modality figures out.
So the big question is, how do we actually draw all these rules on our blueprint? Well, data architects have this really simple but powerful visual language, and it's called crow's foot notation. And get this whole system of rules we just talked about, cardinality, modality, all of it,
It comes down to just 3 little symbols. That's it. You've got a little bar for 1, a circle for 0, or optional, and this 3-pronged thing that looks like, well, a crossfoot, and that means many. The real trick is learning how to combine these symbols to tell a story. Here's the key. You always read the symbols at the far end of the connection line. So, from the professor's side, you look across and see a circle and a crow's foot. That means a professor can teach 0 or many courses. Now let's read it the other way. From the course's side, you look across and see 2 bars. That means a course is taught by one and only one professor. That one and only one is a super common rule. It means the minimum is 1 and the maximum is also 1.
All right, we've got the theory, we've got our building blocks, and we even have the visual language. So now it's time to put on our architect hats. Let's actually do this. Let's build a complete blueprint for a university registration system.
And the process is actually really straightforward. It's just 3 steps. Step 1, we find our key nouns. Those are our entities. Step 2, we list out all the properties for each one. Those are the attributes. And finally, step 3, we connect them all together using relationships, making sure we carefully define all those rules with cardinality and modality.
Now, one of the trickiest situations you'll run into is a many-to-many relationship. Think about it. Many students can enroll in many sections of a course, and each section has many students. Trying to link them directly, it just gets messy. It's a bad idea. So, the really elegant solution is to create a special entity that acts like a bridge. We call this an associative entity, and in our case, we'll call it enrollment. Its entire job is just to connect one specific student to one specific section. It completely resolves the chaos.
So, after we've followed all those steps, defined every single entity, and locked in every single rule, we can finally put it all together into our complete blueprint. This one diagram is about to show us the entire structure of our whole university system.
And here it is. Look at that. This one picture is just so powerful. You can literally trace the rules with your finger. See? A department employs many professors. A professor teaches one or more sections. And look, right there in the middle, there's our special enrollment entity, linking a student to a specific section. Every single business rule we've talked about is right here. Clear, visual, no confusion. And the best part? We've designed this entire complex system without writing a single line of code.
So, the next time you're thinking about a data project, just remember this process. The best systems, the most powerful, the most elegant, the most stable, they aren't built on a mountain of complicated code first. No, they're built on a solid foundation of clear, thoughtful design. A good blueprint isn't just a nice-to-have plan. It is literally the difference between a project that succeeds and one that fails.